some point after 5:30. So you have to get sucked into something. No, I don't spend 10 minutes on this computer.
Good afternoon, everyone, as we are sort of coming in. If anyone would like to sign up to be our notes taker in the notepad, we would be thrilled. I think we're actually, I mean, we should probably give another couple of minutes because we're just post lunch, but
Okay, good afternoon, everyone. So welcome to Madrid. Welcome to our SCONE working group meeting. So glad to see all of you guys in Madrid. So this is the third working group meeting for SCONE. And thanks everyone to manage to come to this meeting. Note will apply. As usual, this is a reminder for IETF policy rules, including IETF process, RPR rules, and working group process. Please bear in mind all what you said, including audio, video, and meeting minutes, will be publicly available after this meeting. And then please make sure to follow this IETF process and the rules. And for more detail, please refer to the BCB document below this page. Note really well. And so we have meeting, and it's normal to have a debate. So please be the good citizen and respect each other. Focus on technical discussion. Meeting tips for in-person participants, please make sure use data tracker account to sign into this session. And recently we have new requirements for data tracker account. Please make sure meet these kind of new requirements, otherwise you cannot join this session. And the Media Echo on-sign tools will automatically record your attendance. And for each presentation, the chair will use the Media Echo to manage the microphone queue. And please unmute yourself and identify yourself before you speak. If you are not presenting anything, or chair, or you already complete your comments, please mute your audio, take your video off. And this rule also applies to all the remote participants. And especially for remote participants, headset is highly recommended. Administrative, and we have chat and Jabber already integrated into this Meeting Echo as a chat window. Please have to keep an eye on this discussion in the chat window and relay and forward the critical discussion to the meeting room. For blue sheet, we don't have paper blue sheet, but we do have Media Echo on-site tools, and we automatically record your attendance in the e-blue sheet. For note taking, we already sent a link to the chat window. Please have take minutes. The minutes doesn't need to be detailed, just focus on key discussion points. And we also list the online agenda and slides resource for your convenience. Yeah.
Wait, I would like to have somebody as a primary minute taker, so I'm going to do my standard sharing thing of the first person who fails to not make eye contact with me. Good job, Martin, looking away. I mean, I would pick on Marcus, but that's like, no, that's a bad idea. Other people with M starting names, Miria, can you help us take notes? No, okay. Anyone? Wes. That's an upside down M. It'll work.
Okay, for working group status, since the Bangkok meeting, we already scheduled 5 interim meetings, and actually we have interim meeting in each month with time zone rotation, and most of focus on base protocol draft. And I have to say we have made a good progress for the base protocol, since we already consolidated 2 proposals into 1 base protocols. And the open question later we will discuss the cadence for the interim before the Montreal. Second, actually, we already established a working group GitHub, so we make good use of working group GitHub to keep track of all the open issue and resolve the open issue. I think this best practice will continue. And also in this meeting, unlike the previous meeting, we have first IETF SCONE Hackathon project get kicked off. So thanks, Wes, take leadership. I hope we can continue in the Montreal. This is the current document status. We have 2 milestones, and the first milestone is about the base protocol. And as I said in the previous slides, we already, just before this meeting, we adopt the base protocol as a working group draft. So we achieve this milestone. And we also have quite a lot of good, discussion, debate on some of the protocol design and protocol usage. And we also receive a good input to the second child item on the applicability, manageability. And regarding the time frame for these 2 child items, actually the second child item, applicability, we actually lag behind. So we want to encourage more review and input on this child item on applicability. And as a chair, we also will pay more attention to this child item in the future interim meeting and on-site meeting. So here's the goal for today's discussion. Top priority 2 goal actually is review hackathon project outcome from this material meeting, and also we'll revisit the status and discuss the open issue on SCONE base protocol. And 2 open issue we want to highlight is one is the time window integration. The second is the integration of the protocol. In addition, we'll review the input to the applicability and manageability topic. And we also will discuss how to schedule the future interim meeting before the Montreal. So here's the agenda for today's discussion. First, we'll review the IETF SCONE Hackathon project. So we will try to review what we get from this project. And Wesley will take leadership for this. And we'll have 15 minutes discussion for this. And in addition, for time window, we want to highlight this topic has been discussed during the interim meeting, but not everybody to attend this meeting. So we invite Anup to introduce the topic again. The goal is try to explore how time window topic can be integrated into both protocol and applicability. And after that, we'll spend the most time to discuss the open issue. And this will be 55 minutes. And in addition, we will spend 20 minutes to discuss the input for the applicability and manageability. We have 2 proposals on the table. The first is a proposal from Tianji China Mobile. He will discuss the realization SCONE in the 5G scenario. The second is led by Sanjay. He will give update for the use cases draft, which target to the applicability, manageability work item. After that, we'll wrap up and to discuss the next step. Any agenda bash? Okay. This another slide, working remote, and just remind you, please make good use of the mailing list, since most of IETF work done on the mailing list. As a working group chair, will determine the consensus on the mailing list. As a working group member, please make good use of the mailing list to resolve the open issue, to socialize your new draft, and also for some working group topic, whether it is in the scope or out of scope, it will be nice to discuss and post on the list as well. For virtual meeting, we already have a good practice to schedule the interim meeting. We'll continue this best practice. And also, we have informal working meeting. And for example, you want to set up the set up the design team, tag it to specific topic. Please reach out to chair. We are happy to get set up. And just a reminder, before you have this kind of design team meeting, please make sure to make an announcement on the list before the meeting taking place. With that, I think we can kick off our discussion. First topic from Wesley.
The first SCONE photographs of the session, I think. So I'm going to summarize what happened at the hackathon earlier this week. All the work was done by everyone else, but I'm just having the pleasure of summarizing it. There was a large number of people actually Saturday and Sunday participating both in person here and virtually in the IETF hackathon. We had a table for SCONE and we filled up the whole table. And there were some other people working remotely who would have needed a second table if they were here in person. What we were trying to do, though, is take this initial specification that the working group has adopted and do two things with that. Make sure everything is clear in the spec so that implementers can take it and build pieces of code that work together from it. And then also test between quick clients, quick servers, and network elements that are supporting SCONE, and make sure that it worked consistently between them. And towards both of those goals, we achieved quite a bit. I'll show in this set of charts. So I won't read the list of all the quick client and server implementations and in-network implementations that people worked on, but you can see from the list that there were quite a few different client-server implementations and several in-network implementations that people were building SCONE support into. There were also a bit of work on scripts to orchestrate tests, and someone took a side quest and worked on getting Spinbit working in Google Quiche. The configurations that we managed to test were a little bit smaller than the list of everything that we worked on. So several of the clients and servers got to the point where we could actually test with them. And we tried those with two different network elements. Things we were looking for in testing were whether the transport parameter could be negotiated between client and server, whether the clients could actually receive SCONE packets and send SCONE packets successfully all the way through the network paths. Summarize, we had a really diverse group, and we were taking the initial spec, so it was surprising that we were able to get as far as we did in testing. And we actually got not only multiple successful implementations, but some successful test results even over the 2 days. So I think it speaks well to the simplicity and clarity of the spec and what we're doing in the working group. And there's more successes than even made it onto this chart, actually, because people kept testing a little bit and made some more progress after Sunday when when we worked on the charts. So notably, we got 3 different clients working with one of the servers, and we had another client work with another one of the servers, and I think more clients worked with that server later on in the week. We also had some good success with getting one of the network elements to be updating SCONE packets and passing them through. Additionally, so not everything is perfect in the spec. So we found a couple of small issues that we posted to GitHub. Just some notes to capture for posterity in the future. We did establish a Slack channel on the Quick Dev Slack called SCONE Interop. So people that are interested in future interoperability testing should probably join that. And I think we could continue to use it going forward to Montreal or even in between to coordinate tests people want to do. And then these are not like IANA values or even proposed ones, I think, at the moment, but these are just some of the constants people are using in some of the initial implementations for testing right now. So Brian actually tried to obtain scones, but he failed and got pseudo scones instead. So they're difficult to find in Madrid, apparently. The things that we posted to GitHub as issues, I said were pretty small. I think you would agree that it should be clarified that there's no need for anything other than a 0 length value for the SCONE transport parameter. And then there's a suggestion to make sure it's mentioned that when a middle box updates the SCONE rate guidance, that it also updates the UDP checksum. Otherwise, packets don't get delivered. And additionally, through some conversation and questions, we had some people that were actually fresh to SCONE, had never heard of it before the hackathon, and came and actually got successful code working. But they had the question of when to actually send the SCONE packets themselves. It's not abundantly clear in the current internet draft, so that could be improved. But in general, it was a great result, and I think everyone feels that the spec was simple and clear enough to proceed with implementations on. And then we made some test matrices to summarize the results from client-server compatibility and host to network element compatibility. And like I said earlier, we actually had more test results, so there should be more green X's or more orange X's than these 2 charts actually convey right now. And I think it gives us, in general, a basis for future tests and maybe another interop event at the hackathon in Montreal. So that's all. Any questions?
Nice work.
All right.
All right, then next up, Anoop, do you want to come talk about the time window suggested bit rate topic? As soon as we get the slides up, run back, but oh, you got to stop that one first.
Hey all, just to set the expectation. So as Quinn mentioned, I'm going to present the same material that I presented in the last interim number 6. So for some of the people who were there in interim 6, it might be a repeat of the same information, so please bear with us. Mainly we are doing this repeat presentation for the folks who could not join interim 6, and it may help refresh for the people who joined the interim 6. Just to set the set the room. So the topic is basically about, we are going to present the experiment results that we have done in the lab to help assist with the time window duration, which should be used to measure the bit rate. Basically, the idea here is to share the results from the lab, and that those results can be used to uh, can be used as input in deciding the what should be the right value for time window duration. Next slide.
It's not doing the thing. Hold on. Oh, it lost slides control when we there. Try again.
So this slide I put for the interim because I thought I may not get enough time. So at least I will use this slide to present the key recommendation from the experiment. But I'm going to skip this slide because we have enough time for a session. And we'll come back to this slide again at the last of the.
Why did it? Hold on, I'm on it. Here we go. Go. Try again.
So quick recap on the context and then the problem statement. So at a high level, the way SCONE is supposed to work. So basically at a high level, SCONE, we are defining SCONE protocol in the SCONE working group to enable network elements to send advised bit rate because of based on any specific video policy to application endpoint, and application endpoint is supposed to do self-adaptation, and network element is supposed to remove the throttler or rate limiters from for those flows. So at a high level, how it is supposed to work is, and it is a very high level things, it is not exact details. Application indicates support for SCONE, and then network element sends advised bit rate to application. Application self-adapt to advised bit rate, and network element is expected not to throttle the flow. The key point here is network element is going to measure the bit rate over a averaging time window to verify the conformance. So the problem statement here is like what should be the optimal value of time window which is acceptable to caps and CSPs. When we say acceptable to caps and CSPs, in the sense it should not be too restrictive from the caps point of view, so that they don't have to modify their video delivery mechanism. The flow should remain bursty. We'll talk about burstiness, advantage of burstiness. And from CSP point of view, it is important that duration of time window is optimal so that the overall objective of limiting the bitrate remains, because if you keep the very, very long duration of time window, the purpose of rate limit may be lost. And this issue, some of the discussion happened in issue number 20. And if we have put some consideration with respect to how we should arrive at a time window. And most of the discussion in the context of streaming video applications and mostly influenced by the short form video applications. So the short form video applications, which are streaming applications, they are bursty, and basically there is a lot of long burst and then followed by idle period. Bursty traffic profile is good for users' quality of experience. It is very important for mostly for the short form video also, because in the short form video, the observation is because the length of the video is so small, then any stall, any delay for the user, it becomes very irritating. So timeliness aspect of the video delivery is very, very important. And in addition to that, aspect related to prefetching, because the user can browse or swipe the video quickly after 10 seconds and want to see another video. So the server should be able to provide the new video in a very timely manner. So basically, if you consider very efficient delivery of video in timely manner and ability to deliver other videos which user can watch randomly, it makes data to be transferred in a bursty manner. So it is expected that the video delivery will carry a lot of data at the beginning, followed by idle period to make sure that user does not see any stall. So I have put a link to the presentation that was made in Brisbane IETF 119, and this is just to highlight a point. If what we have done is, like, if you remove the shaper that was there in the network, and for the same tonnage, what we proved using the data and the experiment we have done in the lab, for the same tonnage, if you do self-adaptation, because application knows how video is getting delivered. Uh, we can keep the burstiness of traffic. And generally what happens is shaper does not know how video needs to be delivered, so they do shaping and makes the flow flatten. In the process, it introduces delays and the quality of experience degrades. So for the same amount of tonnage, with shaper and without shaper, with self-adaptation, we have proved that quality of experience of the user was better. Same experiment was done by YouTube also, and they presented the same data in their presentation in Brisbane. So the key point here is it is important that we maintain the bursty traffic profile when we are doing the video delivery. And when you are kind of making it constrained by reducing the time window size, it may so happen that the data delivery becomes kind of consistent bitrate or constant bitrate, and may introduce a lot of delays and may end up having a stalls from the user point of view, and user experience might be degraded. Other side advantage of bursty traffic is from the RAN efficiency point of view, both from data channel and control channel point of view. If RAN has a large data coming from the application which are capacity seeking application but not a latency sensitive application, RAN can schedule entire data in one subframe, one TTI, and it does not need to, it can make use of their features, which is going to increase the capacity, for example, carry aggregation or multi-user MIMO and MIMO. And it can also use less number of control channel to send the data over to the user. If the data is coming in bits and pieces consistently in the RAN, so RAN, to send the same amount of data, RAN has to use multiple control channel, and it is not very efficient. Similarly, we have done experiment in the live network where we have seen that if the data is bursty for the streaming applications, the UE battery power was improved because UE was allowed to go into long sleep cycles. But if you keep sending data consistently to UE, small amount of data, UE needs to be remain awake for longer period of time, and again it reduces the battery power. Now, so these are the advantages of streaming video applications. Now, how do we derive it? What is the optimal value for the window? Now, different applications, even though they are similar kind of applications, they are streaming applications, not from video applications, but they prefer different window length. They may have different burst profile. Reason being, different application can use different buffer size on the video player side. They may use different segment size. It can vary from 2 seconds, 5 seconds to 10 seconds. They may decide to pull the data from the server at different thresholds. For example, some application may try to pull the data once the buffer threshold has gone down to a certain level. Some application can wait for longer, and their target visual quality metrics might be different. So putting together all, and they might be having different prefetching strategy for different applications, different videos which are not being played right now. So if you put all this thing together, different applications of the same nature may prefer different window length because they might be sending, even for same tonnage, they might be sending data in a different burst profiles over the wire. For example, some application can send large burst and remain silent for long duration. Some application may send smaller burst because they might be pulling data for a smaller segment size, and they may have a followed by the with the idle period. Now, current value, which was proposed in the protocol document, 20 second, it was, we thought it's restrictive from video services, and it may end up impacting the QoE in similar manner what we have seen with Shaper. Because there are two aspects of quality of experience. One is visual quality, and second thing is timeliness metrics. If you get a bitrate constraint, it can be met by the ABR by reducing the quality lane, lower resolution, but that is going to impact only tonnage. But if you have to reduce the bit rate, and if your window size is restricted, then you have to start doing pacing in the transport protocol to reduce the bit rate.
So Anup, we're 10 minutes into 15. Can we get to the results, please?
Sure. Yeah. I'm just setting the context so that
Yeah.
we understand the result in the specific context. So the idea here is, like, if you restrict the length to 20 seconds or smaller, we need to do a lot of pacing, and that may end up resulting into a lot of delays like we used to see in Shaper. and overall the quality of access may go down. So main objective is to limit the tonnage by capping the visual quality, plus reducing some of the peak bitrate by adding some pacing. But it should not end up making a video a consistent or constant bitrate service. It should remain still as a bursty service to meet the QA quality of experience. So objective is to specify longer window to accommodate different application, but not too long, because if it is too long, then it will lose the purpose for CSPs to put a rate limit. In the issue number 20, there was a lot of discussion happened in the context of what should be the basis to decide a time window duration. And we have just summarized all the aspects that got discussed. One thought process was to use RTT, but the challenge with RTT is it can have wide range. On cellular network, you can have a different RTT. On satellite network, you can have different RTT. And again, RTT values will be all in terms of tens of hundreds of milliseconds, depending on the network. It's so small that it can be very restrictive for video services. Second suggestion was use video segment size. Again, a different video service use different segment duration, and it may not be even known to the CSPs, so they cannot use it as a window size duration. Third was use video playback duration. Again, this is a very value. It can be a few seconds to many minutes. Again, it will not be known to CSPs to decide on the time window duration. So finally, we decided that the best way is to see how traffic is transferred over the wire for different applications and make them as a basis for defining time window duration. And that made us do experiment in the lab. So we did an experiment lab. We used a cellular setup. Quick overview on the setup. So we have put a LTE setup, which is a real network setup. And it was a FDD setup, 5 to 10 megahertz bandwidth, best channel condition. We use only one user to avoid any contention or resources. And on the same user, we used four different short form video applications, which are commonly used applications, in a sequential manner, and measure the average bitrate for each app for different averaging window values. And the key point here is we have used, we measure the bitrate on the SGI or N6 interface, because this is where the CSPs are going to measure it. If you measure this bitrate on the UE side, you might get different results, because the way data is being transferred on the packet core side, may be different the way data is getting transferred on the air interface, because air interface plays its role. Scheduler comes into picture, so it may change the burstiness of the traffic. So you may get more accurate result if you measure it on the network interface. So the key observation from the test results, one is because the protocol is specifying multiple bit rates ranging from kbps to gbps. So lower is the advised bit rate, longer is the required window size. So basically, if CSPs are advising very small bit rate, it will require larger window size to meet that requirement. And again, it depends on different applications. So we have used 4 applications. Different applications resulted to different window size requirement for same bit rate. We used 2 different methods for measurement. One is sliding window and second is block window. The main reason here was sliding window. We use sliding window to take care of the scenario where if the CSPs, they care about the window start time. So for example, if they know that if they want to make sure that when to start do the measurement, sliding window will help there. If they don't care about when the window is starting, they can use block window averaging. But overall, it did not make any difference in the overall observation results. So block window averaging results, if you see here, generally, typically in the field in mobile networks, the rates that is registered by the CSPs are in the range of 1 Mbps, 1.5 Mbps, and 2 Mbps. It is very unlikely that you will get a rate limit for every connection 5 Mbps or 10 Mbps. So I think the most relevant number to look at is 2 Mbps, 1.5 Mbps. And if you see most of the 3 applications, they require 90-second or more than, like some applications requiring more than 120-second window to meet 1.5 Mbps.
Can you move on to the conclusions, please? We are at
Yeah.
time. And then, Martin, you're already up. Okay, cool.
So if based on the experiment results, 120 seconds seems to be a reasonable value. Why we are saying 120 second is reasonable value? Because if you go back to this chart, for 2 Mbps and 1.5 Mbps, those are like the real values that is used by CSPs. Even 120 second is not enough, but we expect, this is based on the, when the applications are not doing any self-adaptation. So we expect that through the self-adaptation, by limiting the video quality, by doing some pacing, this results will improve. But we are not sure whether results will improve so further that it can be used like very small window size, because if you have to do a lot of pacing, it may impact the QoE. So we decided, like, we thought 120 second may be a reasonable value to meet this kind of bitrate requirement. And there were two things we discussed in the context of bitrate measurement. It is important to specify the overall mechanism to be used by CSPs to measure the bitrate on the network. I think that should be addressed in the applicability measurement document. And then another question was aggregate or per flow measurement. That is also a topic that is going to influence this time window discussion. That should also be discussed separately.
Thank you very much. Martin?
Martin New Google, I just want to clarify. So your recommendation is to change the constant from 20 to 120, not to have like an app-dependent constant, or not app-dependent setting.
No, I think because it will be applied to all the apps in the network. So it has to be one value for all the apps, and we should use a larger value which works for all the apps.
Excellent. Thank you.
Mosinati, I must be missing something fundamental. This sounds crazy to me. I thought the whole purpose of SCONE was to remove a pacer by having well-behaved networks and services that understood each other's limits. What is the resource we're trying to protect that is monitoring things at 20 or 120 second intervals? Certainly not a network, certainly not most service providers' ingress links. So or egress links, what resource is monitoring something at 120 second interval and allowing a giant burst in the first 1 second of that at gigabits and then idle for 99% of the time? That doesn't make any sense to me.
So again, we are not suggesting to allow giant burst. We are saying it should be, it's not that restrictive. It is going to start impacting the quality of experience. So if the bitrate is advised, it is expected by the application to reduce the burst size by reducing doing some kind of pacing, as well as reduce the overall tonnage by selecting a lower quality lane. But in the end, if you keep the window size so small that finally you start ending up the quality of experience, that should not be the window size. That's what we are recommending right now.
But if the services advertises a certain rate over 120 second window, is that of any use to the client? It could do almost anything with that within that profile, right?
If you see the data, I don't think these are unreasonable expectations. Data should speak for itself, right? So we are just presenting data that what we have seen in the lab. These are the top 4 like most used apps in the field and the short form applications. So we are just presenting data as it is to help with the. So there might be some hypothesis what should be the time window, but we are just presenting the real data, and data should speak for itself. Like we should not bring down the window size to so low that application has to do a lot of pacing, ending up with real bad quality of experience for the user, and that's what matters.
I'm sorry, I don't see any value of this if the point of it is giant windows and you can do anything within that giant window. I don't think you get any confidence that the client is going to behave properly within the confines of the true resource limit, which I thought the whole point of SCONE was there is a true resource limit somewhere and we don't want to exceed that. And I don't believe anyone has a true resource limit at timescales of 120 seconds.
Okay, I think this is which we need to clarify this. So these rate limiters in the context of SCONE work group, these rate limiters are put by the CSPs to support different data plans for different subscribers to limit the data consumption. Second is to limit the egress toward the RAN. So it is not about the RAN congestion. We are not talking about RAN congestion. We are not talking about saving the RAN resources here. We are talking about supporting different data plans for different users. So it's mostly about like reducing the resolution for that user and reducing some of the peak bit rate. That's all.
Mark Zieler. Yeah, I just want to make a quick comment. I think, yeah, it's mostly about some kind of policy enforcement. So it's not really like protecting a resource in that sense. But I think one thing that we kind of lack a little bit in the discussion here is, what is this conformance window? Is this, like, if say that you measure a gigabit spike, will you be silent for the rest of the 120 seconds, or is it a conformance window that triggers you to change your behavior in the network? I think it matters a lot, because the way I have been thinking about this is that I will measure conformance, and if I detect non-conformance for some definition of non-conformance, I will put that flow back into a token bucket policer or shaper. Probably won't be silent for like 119 seconds. So I think this is something that is very non-discussed right now, and I think we need to kind of come to some consensus of what we actually mean with this conformance window as well.
Do we believe that that is covered in the issue discussion on this wider issue, or do we need?
I think we will discuss it there.
Okay. Do you think we need to discuss it as part of that issue discussion, or do we need a separate issue to track that?
Let's start the discussion here, and we'll notice
cool.
that, I think.
Good.
Very briefly, Eric Kinnear, Apple. I would just echo something that Mo said with a operational experience. We have discovered at least one provider that was using a not massively dissimilar from 120-second time quantum to measure bit rates and things. And that resulted in a very bursty pattern in which we would burst real high and then discover what appeared to us to be a completely dead link for the next minute or two, which ended up not being a better quality of experience, but rather a completely broken quality of experience. So I would be careful with lengths of time that make it really, really hard for a user to recover from having done something wrong. But again, to what Marcus was saying, like, I think there's a difference between this is what I'm measuring to see if you're being bad versus this is how I'm enforcing it. If you're measuring it to see if we're being bad, then but if it's actually involved in enforcement, the consequences of doing something wrong here are so bad the user can't help but notice.
Yeah, I think it's an important point. So we are not recommending that just to meet the conformance, application has to change its delivery behavior. What we are saying is, if application has to burst followed by idle period, we should not constrain that burst. So application will deliver the way it's supposed to deliver. It is not supposed to change its behavior because of its conformance.
So Chris Box, I work for BT. We run a mobile network in the UK. We don't actually do throttling of video, but we do obviously have to manage capacity, and we have to invest to expand the capacity. So if we were in a situation where we suddenly had a business requirement in order to do throttling, I wouldn't have a problem with the long duration per se, as long as the implementation in the core is efficient. But the concept, I think, that is being proposed is the business requirement would be to lower the expansion of the network that is needed, the capex, the investment, and that's based on the tonnage. So it's how much data needs to be delivered in a particular area, particular part of the country. And so hypothetically, if we were to set a lower SCONE advised bit rate, that would influence the tonnage down, and that achieves the end. It doesn't matter the fact that you consume as much as you want at the start of the window. That's fine. That's normal congestion management, and the normal scheduling will take care of that. So so in summary, yeah, not a problem, I think. My only concern is within the packet core, whether that, if you have to have a shaper that is watching for this limit not being breached, then if you have a 120-second duration, does that imply a lot of resources needed? But the radio networks, I think, should be fine.
All right, thank you very much. I think with that, we are going to the open issues discussion, correct? Martin, Marcus, do you all want to come up? How do you want to do this?
Hello. Okay. We're going to talk a little bit about a protocol update and open issues. And realizing it's been a long time since we were in Bangkok because we had so many interims. So last time we met, we actually didn't have a protocol draft adopted or at all. But we have one now, and it's version 2 already. So stuff has been happening. We call it SCONE now. This whole thing has had a lot of names, but now it's called the SCONE protocol. It's largely based on the original train draft. And the basic idea here is that SCONE packets uses quick long headers and 2 versions. And you use these 2 versions to encode different ranges of throughput advice. And the throughput advice are encoded in the lower 6 bits of the first byte of the long header packet. Last time we talked about this concept in Bangkok, we were talking about having some kind of overlapping ranges of throughput advice, but what we do now is that we have non-overlapping ranges of throughput advice, and we state that endpoints always generate packets with SCONE version 2, which is the higher range, and set it to the highest value. And then the network element, when it changes the throughput value, potentially changes the version field as well if it needs to express something in the lower range. And we see that the protocol wire format is functional as is, as we could see in the hackathon presentation here earlier by Wesley. So it's just a short update of where we are right now. So let's instead jump into the issues. So the first issue that we want to talk about is one of the older issues we have here. It's around something we call early indications. It is issue number 5 in GitHub. And we're going to start by presenting some background here to the motivation for why this was brought up as an issue. And then I'll present a little bit of arguments for and against it and so on. And then we'll hopefully get to some resolution of this discussion. So one issue that has been expressed by several network operators who are interested in moving from doing their current policy-based video throttling that is based on DPI and parsing of SNIs. One of the motivations to go to SCONE is that you could simplify or make it cheaper to detect traffic that you want to throttle. So currently they use SNI-based flow detections. They would hook up into new UDP flows, decrypt the quick initials, extract the SNI, and then based on that, they can check their policy engine and see, okay, this fits to whatever policy I want to apply and apply that policy. It would be nice if SCONE could obviate the need to do this, and this could potentially then also help enable ECH. We know for a fact that there are deployments of ECH that are being held back because of this, because of the requirement of looking at SNIs right now. So there is a risk that without the indications, there is not enough incentive for some of the network operators to actually start deploying SCONE. And then, if there's minimal uptake in real networks, then what are we doing here? So that was a little bit of the problems. Of course, there are a lot of concerns that have been expressed with this. There has been, if you go to the issue, it's a very, very long discussion. So we're trying to summarize it in a very short form here in a couple of bullets. But some of the concerns can be distilled into a few points here. For instance, putting these indications on packets basically create a new kind of fingerprinting vector. Now, if only, say, a certain class of applications would do this, a certain subset of that class of applications would do this, then this would be a way to easily identify them on the path, and then that might not be a great thing for privacy and so on. It can also be so that when some applications start putting these indications on their packets, what's there to stop network operators to just apply their existing policies and use that as a trigger for throttling and maybe not doing the SCONE thing, right? That would also not be a great thing for, that's not really what we want to achieve here as well. So one proposed compromise or solution to this would be to basically allow the protocol to have these early indications, but then we would encourage endpoints to send SCONE indications on all quick flows, not just specifically video flows. If we get enough flows actually marking their packets as SCONE capable, then this indication becomes more or less useless for fingerprinting. It becomes quite useless as a trigger for legacy policies. Okay, yeah, that sounds pretty good. But if we do that, like if SCONE is used universally and everybody would put their indications there, then why would we need an indication at all? That's another question that pops up, right? And that's where we also spend a lot of time discussing back and forth. And I think the answer to this would be that even though a large number of applications or endpoints would start marking their traffic as SCONE, there will likely be a transition period where CSPs would want to maintain their current DPI-based policies for non-SCONE capable traffic. Basically, there could be video services that are not yet adopting SCONE. If you're applying SCONE policies to them, maybe I think there will be a transition period where you would like to maintain your legacy policies for some time being. And it's if you see traffic that is not SCONE, you can do your DPI-based detection. You can apply your legacy policies if you so wish, and then you can kind of gradually adopt SCONE into your network policies. Now, assuming that all traffic is SCONE means that you're bypassing the legacy policies. So yeah, these are the concerns, and these are some of the answers, and where we would like to come, and I'm like happy to take any comments at any point, but where we'd like to come is that we can get to a point where we would like to either agree that we design something or we don't. So if we design something, I think we would have some very simple requirements. The indication should be part of the first datagram so that it can be used it can be detected by the network element as a way to bypass their trial decryption of quick initials and so on. I think that would be an important requirement of this if we do this. And whether we do this is something I guess we'll have to agree on here on the list, but what we would like to achieve today is kind of come to a closure on this very, very long discussion. So this is a little bit nudge to the chairs. We would like to maybe see if we can get some answers here. Like, are we supportive of including indications in this protocol in some form? I mean, we'll have to design that form. And if there is consensus, then we can actually start designing these mechanisms and see where that takes us. And I would be very happy to take any comments or questions.
So I think I can speak on behalf of the editors of the document. We all think that it's more important to have an answer than it is to have the answer we prefer. So, and we discussed this yesterday. So I'd like to sort of see whether or not the working group also has that opinion, and as to whether this indication is a make or break for them. And if there is a significant interest in one way or the other, then maybe we can use that to decide the question. Other than that, I think the classic design decision-making processes, like tossing a coin, are on the table. If anyone has coins, I don't know that they're much in use anymore. I might have one in my bag, I don't know, but we could work something out there too.
Kyle Eckerts, just to clarify, what exactly are we indicating here? Are we indicating support for SCONE on a connection, okay, so we're not indicating that the connection is going to carry video traffic?
Yeah, it's potential. It's indicating that the client can understand SCONE packets. That's the only thing it indicates, because we don't know that the server will actually understand it and be sending SCONE packets back in the reverse direction. But it's an indication that the client knows what SCONE is. Yeah.
Okay, and the CSPs are going to be satisfied this and not do any enforcement.
Well,
Because
there is still some level of enforcement involved with SCONE. It's just that it might look a little bit different than your DPI-based classification. So yeah, the idea is that yeah, operators will be satisfied with this as an alternative to their DPI-based classification. Yes. It also implies that there is a shift a little bit in how you think about how you apply your policy enforcement. But yes.
Yeah, Kulevin, I actually think there is value in having the signal. I mean, the signal is really just like giving you the earliest, most indication that this is SCONE rather than figuring out later. So it has like this feature. I think this is a feature that can be useful in certain situations. And I would rather like to see that we specify it now and then use it and see how useful it is. And if we figure out it's not useful, and nobody uses it, nobody deploys it, you know, then whatever, we predicted the future wrong, but if we don't specify it, we will not see in future if there's any value. I guess the only question is about the risks, but I'm really not sure what the risks are, because sooner or later you detected SCONE, and it's also not a detector for video traffic, it's a detector for SCONE. So I feel like the risks are really minimal.
Yeah, I mean, if it's SCONE end-to-end, you will detect it probably a few packets later otherwise. So.
So if I recall correctly from the interim discussion, I think that really was sort of the sticking point. If we're in a world where we believe that this is only going to be on the first packet of video traffic, then it might be used as a fingerprint. But I don't think that anyone credibly believes that we're in that world. Correct?
So, and I meant to say, I would like to specify the feature, but not have a long discussion about guidance about usage. That's something we can figure out later.
Yeah.
Yeah, so I disagree with Mira. I don't think, but this is not the point of the discussion. I want to know whether or not this is a deal breaker for you, and I didn't hear that. I want to know whether there's anyone in the room who thinks this is absolutely necessary to have, because no one will be able to implement this without it, and I'm not hearing that.
So you will definitely be able to implement it, but the fear is that it will be a deal breaker for deployment.
I'm not talking about fears. I'm talking about facts.
Sanjay, please recap Martin in the queue, unless.
No, I just wanted to respond to Martin also. I thought I would just, but go ahead. No, his question was that, is this a deal breaker? So I think I just want to clarify that. So I started this issue, and the initial thought was to, how does the network that is currently using SNI as a way to detect the video flows, and if SCONE was to replace the existing mechanism, then we want to get away with the current process of how, if SNI is used in the process. So SCONE incentivizes of not using SNI, but follow the SCONE protocol. But the question was that how would the network know that skip the SNI and this is a SCONE flow, so you can do that. So that's why the question of client indication came, that if the client were to give an indication, then that's it, that's a trigger. Ignore everything else. This is a SCONE capable flow. So let the SCONE take the precedence in terms of what video rate should be applied. So that was the question. So long story short, this is really a critical feature that basically allows the operator to look into replacing something that they follow today. I don't know if that answers the question, but I think it's definitely something that speeds up positively for SCONE to be deployed in the network. But if SCONE is not offering any benefit over the current process, then the utility of SCONE is not there as much.
So that sounds a bit like a deal breaker. All right. You locked the queue, I saw.
Yes, I locked the queue. I'm trying to figure out. Martin, are you? Okay, you're fine. We might reopen this in a second. I'm trying to phrase this. So there's two approaches here. We could flip a coin. Martin has kindly offered to make one available. We could phrase a question to the working group. I think you know, I mean, I don't necessarily as chair want to be replaced by a coin just yet. So I think I would prefer to come up with a question that we can get a signal on. Martin, if I can rephrase this in a way that we can put this into the thing, the question is, do you believe that it is necessary for SCONE to require a first packet indication of SCONE support from the client? That's okay.
When you say require, you mean that it's not optional, or?
That like, if you're starting a connection, you must indicate.
You must indicate. Okay.
That's what I think.
Right.
That otherwise, like these are the only two choices, right? Must indicate or nothing, as far as I understand. Okay, yay, we can read
No,
the queue.
no. So the intention here is that this is an optional feature for expediting the deployment of SCONE in real networks.
So we create the thing. A client may choose to do this, but must not.
Yes, and we
Does not
strongly
have to,
encourage
yes.
that you do that on all quick flows. That's
Got
the
it.
idea.
Okay. And to the point where we're gonna put a should in there and explain our should around.
Yes.
Okay.
Yes,
deployment
but
considerations. Okay.
the expectation would be that this is not a requirement for SCONE, the protocol, to function. This is an optimization for deployability reasons.
This is why I pre-asked the question before asking the question. Thank you very much.
So I think this is where the confusion is coming from. If it's not made mandatory, then it doesn't necessarily mean that those who might.
Are we under the impression that what we put in IETF documents are actually law that networks follow? Because I think this is born out of conversations with network operators where they say this would be a thing that would make it's a carrot, right? That makes it more likely to be deployed faster, right? So what we put in the document is somewhat immaterial to it existing at all, which is kind of to Miriam's point, which is like you put it in the document, you have the deployers of the endpoints use it all the time to get around some of the concerns, and then you hope that this is enough of a carrot to get it actually deployed. Because otherwise, why are we here? That's the idea.
We would only do that if it was absolutely necessary for some deployments that it be there, right?
Right, and I think Sanjay's comments sound fairly strong. Like if there's not utility for a network to do this, then they won't do it, is how I hear those comments.
Yeah, I thought we had enough of a case in the protocol itself to justify that.
I don't run a network, but I've talked to people that run networks, and that is the takeaway I've gotten. So.
All right, so yeah, come on.
I mean, these last couple of words really make me a little bit sad, because we learned the lesson way too often that just having a fancy protocol is not enough to get people to actually invest the money to deploy it, right? We have to maximize what comes out of the protocol in order to make sure people understand the incentives, or like we must understand their incentives, why they deploy it. So I don't want to see this error to be made over and over again.
Yep. So, okay. Again, attempting to avoid being replaced by a coin, but I am willing to go there if we must. I'm going to start a show of hands now that is based on the should indicate language just proposed by Matt. So should SCONE support, I can go ahead and click start. Should SCONE support first client packet indication of SCONE support with should indicate language? I can attempt to phrase that in a more confusing way if we are. Someone's in the queue. Ben.
Hi, Ben Schwartz. I just really want to understand this concept of support.
Which one? Apologies for that. I
use the word support. I want to know what that means.
Oh yeah, okay. The first support should be include.
An indication that this client will attempt to comply with the advice versus an indication that this client can tolerate receiving the advice without.
It's the latter. It must be the latter. It's like the client can tolerate receiving advice. That's the only thing this indication can say. You cannot make any other guarantees with this type of indication.
Well, I mean, we can specify the meaning however we want. It could mean
Yeah, of course you can, but it's like it will.
But that's not the intent. Okay. Thank you. I'm having difficulty understanding how this is valuable to a network operator to know that a flow might or might.
Okay, I will try to be as succinct as possible. If you have an indication, you can avoid as a network element from doing trial decryption of a quick initial to determine if you should apply a then expensive policer. So the alternative right now is they have to sit around and wait for SCONE packets to show up, which means that they have to track SCONE packets coming down. That's it. That's the only benefit. You avoid trial decryption of quick initials.
But you have to apply a policer. The only way you get to stop applying the policer is if the flow respects SCONE. But what I'm just been told is that this indication doesn't mean that the flow respects SCONE.
It's a leap of faith that we believe that they will be willing to make, based on both conversations with the people that make the equipment and the people that buy it and put it in networks.
And that ties back a little bit to the conformance measurement discussion.
I'm not talking about whether it's a guarantee. I'm just talking about the intent. If the client puts this indication, is it attempting to convey, I intend to comply with your SCONE advice, or is it saying I might ignore, like I'm putting this indication in, but that just means I might log your SCONE advice. I have no intention of acting on it.
From a protocol standpoint, it is only indicating support for SCONE, the protocol. We're not saying anything about the humans that run the applications behind that.
Okay.
So there are two cases. One is you see the indication, you don't do deep packet inspection, you keep monitoring the flow. If you not confirm, you turn on throttling. Case one. Case two is you don't see the early indication, so you have to do deep packet inspection, turn on throttling immediately, and only if you maybe later see a SCONE packet, you turn it off, or you might just keep throttling because it's not worth it anymore. I wanted to comment on the question. I think actually the second part was with should indicate language is not necessary here, because that's what I meant. Like we should specify this feature and we don't need to say much about its usage requirements, because people can figure that out if it's useful.
Right, because if you don't have the feature, you can't use it, obviously, right? Like so,
exactly.
Yeah, we should. If we think that the feature. Okay, yeah. I mean, there's the corner.
Yeah,
you can't
I mean,
be up
like,
in this corner.
yeah, we
right?
should say something about the feature, why we have it, but we don't need a normative language around it.
Right. Okay. All right. So I think I'm going to do another one of these based on that feedback, but we will drain the queue first.
It seems like we have an answer there, no matter if you.
It's looking. It's looking. I could call that rough consensus, but I do want to hear from DKG.
It seems to me that the mechanism you're talking about here is a way for me to say, please don't apply the shaper to me, but I can lie. And I don't believe that anyone who actually has an incentive to apply a shaper will believe me if I lie. So why are you asking for it?
It's, can I? I think it's the opposite. It's actually saying, please apply a shaper to me, or I will apply a shaper, and if I don't, you can feel free to apply it, because I probably do it.
Yeah, maybe. Yeah. I think it was a good question. I think again it comes back a little bit to how we view how you do policy enforcement. If we are okay with this flag, please don't shape me, and the consequence of putting that is that instead of shaping, you start by some conformance measurement with potential fallback to throttling. Yeah, I think that is something that can be acceptable for a network operator.
Tommy
Pauly, Apple. I think some of what DKG was saying was also what I was thinking, like, and if I understand correctly, it seems like we want to say to not stick out, we're going to mark this on all quick flows at some point, which means at some point it's just like all of the traffic is going to do this, kind of regardless if it's actually doing SCONE. So like the signal is just going to degrade very, very quickly. So I question a bit of the use here. And
I guess a
Oh, wait,
question
hold on.
from.
I have a clarifying
Sorry.
question on your question.
Please, yeah.
So basically what you're saying, the picture you're painting is one of nobody implements SCONE, everybody implements SCONE, support indication. Right?
Well,
like everybody just reads enough of this
currently there's
RTF.
nothing there. At
Yeah.
some point, every single quick flow will just mark this all the time. There's a little bit of a time in there where it's like people are
there's a rollout.
upgrading and you're really building this mechanism for that short window of time. And I guess I'd like to think ahead to that future bit where like you have to deal with all these flows kind of being the same anyway. I wonder if have we done the homework enough on the recommendations for what that operator would do to be efficient? Like I don't know all the details, right? But like it feels like there may be a better way to have some heuristics around when you can try like to make yourself efficient based on what you know about the server supporting SCONE and kind of what you've seen for the percentage of clients that are doing that. Like if that's possible, and if that's going to be kind of where you have to end up anyway, because every flow is going to get marked with that, then I really don't see the value of this extra signal on the side.
I agree with that. You probably, I mean, I agree with some things you say. You definitely need to do, you definitely need to do something. You see an indication, and in this transition period, that is an indication for you to maybe not look at the SNI. Then you will probably do some things. You will start counting packets. You will maybe look for SCONE packets coming in the reverse direction, and that might inform your actual policy enforcement. But there is a period. I mean, you're saying a very short time. There's the definition of very short is tricky. What I do know from conversations with CSPs is that they really see that if this becomes a vehicle for them to get away from some expensive DPI, this is a strong motivator. Using that indication, at least from the early phases of deploying this protocol, it might just be in an early transition phase where we actually start trialing and deploy this protocol, and we see that we can in parallel run DPI because this is something that is a decision they take on the first packet they see of a flow, whether or not they do DPI. So during this transition phase, if we can see that, yes, you can look at this and you can do the SCONE heuristics and you can see the benefits in terms of performance of not doing this expensive DPI, I think that's a strong motivator for a lot of the operators to deploy this. And that's...
But I guess, so like very, very practically, like, you know, my understanding of when you're looking at SNIs, et cetera, to do the current throttling, like there's very specific policies about where the traffic is going that you have to do the shaping on. And yes, there's going to be some diversity of clients going to those things, but on any given operator network, there's probably going to be only going to be a handful talking to any particular server. So even if like for the moment, they would be looking at the SNI on all the traffic, they could recognize, oh, what percentage of the traffic is later doing SCONE, and they could realize when they hit some threshold or some tipping point. And you could even do things where you say that, yeah, it's actually like all the SCONE ones, once those clients are coming out, they get a different IP address. Like if you have a major split between non-SCONE clients and SCONE clients, and you want the operator to know about that, you could just say, yeah, this is actually just hosted differently. So you can just see that in the flow anyway.
Sure. And
you can know that, yeah, anyone talking to the old endpoint, I need to do the whole SNI thing, enforce that way. And all the ones talking to the new one, they're just going like, I don't need necessarily a flag in here. It's to still be able to do some of these heuristics as an operator.
That's true. I mean, there are multiple ways you could achieve this.
And then we don't end up putting this extra flag forever in every single quick flow on all implementations of quick everywhere. That was really existing for this limited transition period.
Well, no, I closed the queue because I thought I had heard something that would allow me to put another question up that I will try to reword, or I will try to word slightly less confusingly. Like one of the things I'm hearing is that the question of what advice we would give for using this is still more open, right? Like, so it's really what we want to determine right now is, do we as the working group want to take as one of our goals supporting this indication or not, full stop? Do we believe that would be useful?
I'm sorry, Brian, scribe interrupt. I'm falling behind. so this has been a very interesting discussion. So please take a look at the notes and see if I've captured what, or if I completely missed your comment, which has happened in many cases, or I've misrepresented what you said, because I'm trying to understand this at the same time I'm writing everything down and I'm failing miserably. And I thought someone else was doing to do this too. Thanks.
So I'm going to put the simpler question up. I mean, we have like one more big one that we want to do too, right? So. What?
Before we get too many votes, what are we talking about? Are we talking about should the SCONE protocol spec include the first packet?
Support for this packet, should we specify it?
Should
and
we
leave the
specify?
deployment advice for it TBD. Yeah, but can we stick to the queue though? I'm going to leave it up.
You opened the queue,
Yes.
Brian? Oh, thank you. Dan Drutz, AT&T. I have a different perspective on how to look at this, because we keep talking about, oh, should we just trust me that I'm supporting SCONE or not? The way I look at this is that it's just an indication that I believe that this particular connection is going to be a victim of shaping. And I want to let you know, network, that I want to be treated according to, you know, the way the protocol SCONE, the SCONE protocol is actually established. So by doing that, how the network reacts to this early indication is basically up to them. It's a classification in the end. But knowing this as early as possible allows me to make some decisions in the network on how to avoid or not enforcing the policy. That doesn't mean that verification is not going to continue to happen, and and measurements that are not going to work. It's just that an early indication will allow me to do that early decision in terms of how to apply policies or not. And also, oh, I forgot. We do selective shaping. So I do believe that if policy goes along with a certain type of traffic, not from a one particular application. It's just how we do the selective policies is going to be very difficult to actually make that a case for SCONE, unless I know that this particular connection is one that should conform with the policy.
I wanted to make 2 points. First of all, I'm not sure we're ending up in a world where all SCONE traffic has this early indication. If you are not sure, so basically, if you would implement this in the network, as I said earlier, like if you see the SCONE in the early indication, you don't do the SNI, you don't do the throttling yet, but you assume this might be traffic that should be throttled if it's not conformance, and then you might do the throttling later without having done the SNI first. So, this, as soon as you send the early indication, this is in the category of traffic that might be throttled. So if you have some traffic that you don't want to, that like you don't think is like any benefit of getting throttled because it's a certain class of traffic, then you shouldn't probably use SCONE at all. But if you are trying to use SCONE on the client side because you don't know exactly what traffic that is, and you don't know if the other end supports it and if it's useful for the other end, then this is the case where you can try to negotiate SCONE. You don't put it on the first packet, the indicator, because you're not quite sure yet. So there is actually a use case for that. So I'm not sure we will be in a world where all the SCONE traffic will send this early indication, but who knows? We don't know that yet. Point one. Point two is, if there's a value, and there is a value in differentiating SCONE and non-SCONE packet, let's do it explicitly and not like with some mangling with IP addresses or whatever. Let's do it in an explicit way so it's clear and easy and can't get wrong.
Kazuhoku, as someone who was previously opposed to having indications, I'm at least happy that the concerns regarding privacy and misuse has been resolved in the latest round. And regarding the usefulness of indications, without indications, the problem is that we are essentially telling the network operators, hey, what you are doing is wrong, so you should move to the entire new way of applying SCONE for all flows. So that's a huge step for these network operators. And what the indication instead provides is the network elements or network operators the ability to dissect the flows to which might support SCONE, for which the new approach defined by SCONE should be applied regardless of the server supporting it or client actually respecting the signals. So this gradual phase, which might be short, reduces the barrier to entry for the network operators. And I kind of think that there's benefit of doing that.
Agree. David Skenazy. So some of you know me in that I've liked to mess with our quick stack, which is the quick stack behind Chrome and behind the YouTube app on almost all platforms. And I've messed with it in ways that breaks DPI. And I know that because then I get in trouble. But that also gives me a good view into why people are doing DPI. They're not doing it just for fun. And actually, you know, if someone was doing DPI just to invade your privacy, they generally don't come and complain to me because they know how well I'll receive the complaint. But if they're doing for something that's good, that we think is helpful for the users, then we'll listen. In particular, one reason they look at that is they say it's YouTube, they realize that they have a contractual agreement with YouTube, and they set the shaper in such a way that when YouTube self-downgrades itself to a different rate, everything works well. But that's the goal here, is to establish that the application will throttle itself. Here, now we're talking about an indication. If we're defining an indication in this document, it needs to mean something. If it's unclear, then we've just wasted a code point, made things worse. If the indication is I can parse SCONE headers, that's not helpful to anyone. The box doesn't care about that. The box cares that you will send the signal through and like rate limit yourself. So that could be potentially a thing you signal, and that involves not necessarily the video, but something like adaptive bitrate. It means that the content that you're getting can be get different ways and slowed down in that way. And that's not the case for most traffic. Because I think if we just define this as support SCONE, like Chrome will just send it on all quick packets and it's useless because it will know how to parse headers. But if we want an indication, it needs to be clear about what it means and it needs to be useful.
Tommy Polly Apple. I guess, you know, partly to the question, not to criticize the question too much, but like I feel like one question before this, which I would have like a very easy time answering, is like, should SCONE define a recommended approach for operators to efficiently handle the transition and coexistence of SCONE and non-SCONE traffic? Like that, I think is like a clear yes, and like the goal, like let's do that. This is like I'm not yet convinced that this particular marking is the right way and the best way to achieve that goal. And so maybe we should like just do a little bit more analysis of like what are possible ways to do that maybe don't have trade-offs, like, well, then you just mark it on everything and it kind of waters down the meaning. I think part of the issue here is that like there's a potentially a lack of trust in what that marking is, because if I can just mark it on everything, then the operator still has to look at the SNI and it kind of falls back to what it would be before. If we could have a way that was a bit more tied to something else where you have to commit to what you're doing, that might be easier. Which is the only reason I was getting into like, oh, if you know something about the host that you're going to, that is potentially different than just saying, yeah, what stops someone from just marking this intentionally to stop you from SNI sniffing me on every single thing I do to any host in the world.
Which
Like,
obviously would not work, right?
and then
Because
once
you're not gonna start doing
someone
that
does
thing.
that,
Yeah, yeah.
then this bit is useless. So like let's work a little bit harder to solve the goal.
So Christian, and then I've closed the queue, and we'll try to do another round on this so we can get to the next set of issues. We are not hearing you, Christian. We are
Still muted.
not hearing you, Christian. He is clearly hearing us.
And now?
Yes.
Ah, yes.
Yeah, there's a magic button on my microphone. Well, look, I think that Tommy is right there. Is that if it is useless, it will just be another detritus on the headers of the packets, and we'll lose a few bits on every packets because everybody will put that. Now, there are a couple of big things that we can see from an application point of view. First, application should not hog the bandwidth. That's pretty clear. I mean, it's not. I mean, the internet is based on cooperation, so an application shall not do trick to say sustain a large bandwidth all the time despite network feedback. That's one is clear. The second one is that networks are not supposed to differentiate between users. So if I say that we have a policy that says YouTube does something and my little dinky application cannot have the bandwidth because it's reserved for YouTube, I hate that. Okay, so we want to get out of that. I don't think that SNI is stable because sooner or later everybody will apply encryption in a way that completely breaks SNI. So let's go back to what Tony was saying is it has to be a bargain. It has to be a good bargain for everybody. Just not doing SNI as no particular, I mean, I don't care about that. I do care that the network is stable. And so unless that indication, as Toby said, has a clear win-win for everybody, then I don't see the point.
So if he's done. So Brian, I have a opinion and a process point / question. I know the queue is closed. Can I think I need to make a process suggestion, but can I express an opinion as well?
Do the process suggestion first.
Okay. I find this to be very hard to follow. I've been in all the meetings. I remember at the last interim I was reading through the issue, which is now very long, and I detect some. I'm not sure we're arguing about the same thing. I'm hearing like, oh, like this is a thing to tell me not to be shaped. Oh no, this is a thing to please shape me.
I think you're about to give me the process suggestion that I was going to interject myself into the queue to do, but go ahead.
Okay. Well, maybe not. I don't know. But like, I would actually love to see like a fairly thorough PR about this.
That's exactly what I was going to say.
And you know, I know we like to like kind of get take the temperature of the group.
Yeah.
But like something actually concrete to argue over that I can actually read and understand what we're proposing here.
That's how this issue started.
It's not linked to the issue, is it? Okay, because I went to issue 5 and I did not see a PR link, but maybe
maybe it's not linked. Oh, yeah, because
maybe I failed at GitHub. That's
it
possible.
might,
Okay. All right. Great. Okay. I will read the PR if somebody points me to it, and then we can argue about it later.
Right. No, so I saw a couple of things from, so I'm going to actually try and close the discussion on this one issue for today because we do have other issues that are potentially equally contentious, and I'd like to try and use the in-person time to get through those. So there's a roughish consensus here that it's probably useful to do something. I am going to read what's here as we need to take the input from this discussion into a PR and discuss that on the list to have this closed at the next interim. Or Martin's going to get super angry and flip a coin. Martin would very much like to close out today as we have a closure. Okay. Okay. From what I've seen then we are going to have first client packet indication in SCONE, and we will discuss on the list what the deployment considerations are for that. Is that a deal breaker for anyone? Going once, going twice. Gory is available for appeals. Good. Next contentious issue.
Here we go. Yeah, so this ties back a little bit to Anoop's presentation. There's an issue going on there. There's quite some discussion, not as much as the previous one. So, but yeah, short story. What does throughput advice mean? We're just sending a value. Like what should network elements do and what should endpoints attempt to do to measure this? Martin is in the queue. It's a clarification. Okay, yeah. I thought, yeah. So some questions like we saw the presentation, right? There are some proposals on like average windows. Should we do block measurements? Should we do sliding windows? How much about this should we actually say? Is this something that should go into the base specification? And if it's not, what are endpoints supposed to do with that information? So there is a current proposed approach. It's PR 37. The proposal there is a sliding window algorithm with a fixed 60-second or 120-second minimum window. The important thing here is also what we're specifying is the minimum window over which the network element would enforce or monitor the rate for detecting conformance. It might use a longer window. That's completely up to the network operator. The endpoint, on the other hand, might decide to use a shorter window to apply its own rate limiting, its own conformance, right? So, but the important thing is that we need to find a spot where the endpoints and the networks can kind of agree, so we get some like reasonable interoperability here, and then. Something that's not here as well is actually that we started discussing a little bit, and which probably is not in any of the PRs now, is what actual non-conformance means. Does detection of non-conformance mean that you are like, I'm doing this as a policer, so I'm going to drop all the packets until like my window opens again, or is this a trigger to shift my policy to doing token bucket based throttling? I think this is something that we're not specifying, and I'm not sure if we should. Would be great to hear some opinions on all of these topics.
Yeah, I think the answer to that last question is that we probably shouldn't say anything about that, other than to note that if you do treat this like a policer on a scale of 60 or 120 seconds, bad things happen. So it's probably you start policing or shaping at the point that you detect a violation that is far in excess of that, ignoring whatever has happened. And so that there are factors involved here then. If we make that assumption, then it could be as much as 60 or 120 seconds before the network becomes aware that someone's not following the advice that they're receiving. And so having a longer time might lead to that conclusion. Having a longer time also means that you're less able to steer if circumstances change, and if you start spending at a higher rate than you expected, and you find that the rate limit has dropped, then it takes you much longer to sort of recover back to a steady state. The other thing that's come up in discussions, and Zahed's not here, but he raised this offline with me, is that it would be really nice for this period to also be used as a sort of hold down for when you've received advice, so that the network elements don't have to update every single packet. So one of the things that we were talking about is having opportunities to mark packets quite frequently. And so you can imagine applications sending every burst or every round trip, they send another SCONE packet because it doesn't really cost them very much to do that. But that means in the current design, there's an obligation on the network elements to update every single one of them. And the feedback that I got was, though it is cheap to update them, it is not free. And updating them at line rate on every packet, particularly when you're operating at scale, is perhaps unwieldy. And so the suggestion there was to require the endpoints to use this timer as a period over which you select the minimum value in that you've received in that period, even if you received advice that's higher or unmarked packets.
Yeah. I think okay, that's interesting. I agree that it's cheap. I understand it's not free.
Yep.
I'm not sure if we should have the minimum over that window, because you might have like, okay, say that we have a 2-minute window here, 120 seconds as an example. You have a policy where you set the low thing, and the policy changes, you set something slightly higher. It's still not the top one. So maybe there should be some nuance to that not just the minimum, but I think that I kind of agree with the principle. And we can discuss
right.
that.
There's a couple of things you can do to make it a little bit more reactive, but I think that the consequence of having a window like this is that you effectively are committing for about that long to whatever advice that you're giving out. And so having that be a minimum. And there's a couple of little tricks you can play in implementation that allows you to sort of loosen it off. But the problem is if not every packet is being marked, you might have 2 network elements on the path that are each giving you different advice. And if and that looks indistinguishable from the case where the rate limit jumps up and down. And so you can't respond immediately to those sorts of things anyway, if you allow the network elements to not mark every packet.
So if I could make, I think, a friendly clarifying addendum. What we're actually talking about here is sort of like the signaling master clock, right? Like, so all of the time constants of this protocol are basically based off of this time constant.
Yeah.
They're not all equal to this time constant, but they're based off of it. They're influenced by it. No, they're not? Okay.
So
Myriad, go ahead. Well, yeah, Myriad, go ahead.
No. These things are really completely independent, because the time we use for sending the signal doesn't mean like you can, like if we send it whatever every 60 seconds or different value, doesn't mean that you should change the signal every 60 seconds. This is just the time, the maximum time you have to wait until you can actually signal a fresh signal, but the signal will change at any time, right? Something happens in your network and the advice you want to give change, and then you have to wait a certain time until you can actually signal
not maximum.
Yeah, it's minimum. And I think, I mean, you can start signaling a new rate, but it might take 45 seconds until that rate is actionable, and that might be okay.
Yeah.
If we're going by this.
Yeah. So say someone sends a 10 gigabits per second indication, and then the endpoints deal with that, and they send all of their 10 gigabit per second budget in 3 seconds. But 3 seconds later, the network says, oh no, I've only got 100 kilobits per second. Then they can't comply with that over that window anyway. They've already spent the budget.
So yes, but I mean, what happens is you're not just like randomly thinking, oh, I sent this value today and then I sent this value. It's like something in your network happens, you go into a different cell, you're under different conditions, and so suddenly a different rate limiter applies to you, and it will apply immediately. And then the goal is to get out the advice that applies immediately, which will break the system, yes, but getting out the advice as soon as possible.
So yes, you can signal immediately, but it's not going to change the fact that the window is this large.
It does change it, because you're suddenly in a completely different environment where you don't have knowledge about the old window anymore.
Yeah,
you just have to start new.
The window is what it is, and then there might be conditions, there might be new signals. The question is, when is it actionable? I think that we can discuss this further. I think there's some value to this point, because even if I will attempt to mark every packet, there could be conditions where I just by some random chance am not marking a packet, and I think we need a solution to that. So we can discuss if it's completely tied to this window or not.
That seems like another issue that should be filed in a subsequent PR to 37 to me, though.
I don't. I mean, the point I'm saying is like I don't think it is tied in reality, and I don't see any value why we need to tie it.
Sure. Let's discuss it in the issue.
Yeah, but the thing that I actually wanted to say was currently the PR is really kind of this signal means every 60 seconds happens or something, and I don't think that's how it's phrased. I don't think that's useful because you cannot enforce it. Like, you know, if Mo decides in his network this value isn't the right one, he will use a different one, right? Sorry. So I think we shouldn't phrase it this way. We should phrase it as a recommendation, make clear that like we cannot enforce it, right?
I mean, of course, any network can do whatever they want. What I think we want to express here is a kind of midpoint where endpoints and operators can agree. Hopefully, I mean, of course, there will be networks that do whatever they want. There might be networks that look at the SCONE signal and just starts throttling right away. We cannot control that, right? But defining an interoperable kind of average point where you know, network elements might use 120 seconds, even though it says 60 seconds here, because that allows for nicer bursting behavior, and maybe some endpoint uses 20 seconds because they are realizing that they conform better and get less throttled by doing that. I mean, that's fine. I think it's good to put a value in here that is largely useful. Of course, we know that not everybody's going to do the same thing.
Yes,
and I think we should have ample guidance around this as well, saying what are the consequences. Like if you are a network element and you do this, and you choose 10-second windows instead. What are the consequences for applications, and what are the consequences if an application starts using 120 seconds, but we have said 60? What are the consequences? We can describe all that, and then we see how it goes. Matt had an interesting idea that maybe after deploying this, we collect information, and maybe we produce a new draft saying that, an informational draft saying that this is actually what we learned. We put these limits in here. This is how we played out. Maybe there are new guidance that we can propose based on this. But I think having some value to fix on initially is good.
Yes, I'm not against the value. I'm not sure which one is right one. We should have definitely have a value.
Yep.
Just I'm saying the way it's phrased right now, it's saying kind of this is the value that we all agree to, and nobody can do anything else. And this is how the wording is in the PR right now, kind of a little bit. And I think that is just dismissing reality, because that will not happen. Like, even if it would be nice if we could all agree to something, we all will use it heavily because it will give the best results. There's no enforcement in the interoperability, how we design the protocol. You cannot enforce it. And like, even if you say, if you use a different value, bad things will happen, it will not break the protocol, just like it will not, you know, be nice to the user or whatever. So there's like, in reality, there's no way to enforce that, and we shouldn't even give the impression, because that will lead people to the wrong assumptions.
I mean, I could, like, sorry, Marcus, I'm going to destroy your shirt. I could wash Marcus's shirt at 95 degrees. It will still be a shirt afterward, but you're not going to get best results. It has a label on it that probably says 30 or 40, right? I think that's kind of what we're doing. Probably 30, but yeah.
I'm just saying, because I looked at the PR, the wording in the PR doesn't reflect.
So we can look at the wording, see if it can look more like guidance and less like, but yeah. I think there is some value in putting pretty strong language there, because even if we know that the reality is what it is, it's good to give people, you know, like, this is where we should start doing this. I think
I'm even in for strong recommendations, but you shouldn't put it as a fact, because that would deny that it's not a fact.
Let's have a look at that.
PRs and PRs truthfully accepted, I think, is the we have Tianji in queue.
Hey, Marcus. Here, it seems like for this number, you put like a fix as a minimal 60 or 120 here. If you consider, well, basically, I have the drafted after you talk about the end-to-end architecture, and then when you apply this one to the wireless plus wireline all kind of together here, and then for some QoS requirement on the wireless part for the SCONE flow that are going to be applied. And then it might, actually, it has a different requirement on the average window that's going to be used to measure. So you put this one as the minimal. I can give you one example, like the 5QI. For some QoS, it has the 2000 milliseconds. So basically like a 2 seconds for the average window to measure something. So we have to consider it's like end-to-end, not just for one particular things. And especially you put a minimal, actually it cannot be minimal. 2 seconds is way less than this one.
Yeah, I mean, so there might be things on the path. There might be things out of control of the SCONE element that does things with your traffic. What this says is that the one sending SCONE signals is pretty much committing to measuring conformance over this type of window. If you are applying some MBR kind of session data rate control on top of this, first of all, I'm not sure. Yeah, do you want to signal the SCONE doing that? And if you do, then I mean, the thing what will happen is that this will be detected by the congestion controller of the endpoints. Like if there is something in your network that enforces, like you have some other policer active when doing this, which is, you know, you're free to do that, then yeah, this 60-second window will not matter that much because your policer will probably kick in anyway, and congestion control will take care of that.
Agree, but the SCONE policy can be provisioned through some control plane from external the application function for the 5G to the PCF and the PCC rule that are going to apply to the NE called the UPF there and apply. So basically, it can combine together, not just like independent things. Yeah, if I get 5 minutes later, I'm going to talk.
Sure. I'm happy to hear that. I think there are many ways that this could be maybe configured, and if you're future looking, maybe you would have other ways to communicate values, but what we're talking about here is something way simpler.
So Gori, as an individual, until we got to this point, I thought I really understood what we were doing, and now I'm totally confused why we're not getting more signaling from the network and just setting a limit, and why these two things are interacting anyway. So I just wanted to say I suddenly got confused. So maybe other people perhaps are too. So we need to talk about this, I think.
Yeah, happy to talk.
And Mo will have better opinions than me because he maybe hasn't got confused yet.
Mozanetti, so Tianji mentioned something that I think makes me realize why I'm at a disconnect, and maybe he is too. If you had this very long average rate as one thing you announce, but also a peak rate that you also announce, and that may come from something that's not the direct service provider. It may be informed by something like other providers in the path, and that may end up being something that allows all the traffic through all the time. So instead of the YouTube app saying, oh, I can burst, I can spend 5 megabits, but it's over 120 seconds, so I can send the entire 10-second segment right now at my line rate, and I can go idle for the entire time. Instead of him doing that, he would say, oh, I see the peak rate is also 10 megabits over 1 second, so okay, I can only go for this 1 second at 10 meg, and then pace the rest of the segments out. So maybe having 2 rates, a long-term window average and a peak burst, may satisfy all the providers on the path.
Yeah, it's an interesting approach. I think it boils down to how much complexity we want to add to this protocol. Right now, the only thing that we signal in the protocol is a rate, and then there's a set of assumptions that come with that rate. If we are to add something like a peak rate with this as well, I think that's not something that we could as easily fix on here.
I would just say that you're talking about delivery rates. Every video itself for encoding does have those 2 rates, does have an average rate and a peak rate in the encoding itself. So now delivery maybe should mirror that and should also have average and peak rates for the delivery side.
It's something worth contemplating. I'm a little bit worried about the complexity of this protocol and the solutions increasing. Yeah, maybe we meant another version. Yeah, whatever. I think that could be an extension worth discussing at some point. But
Marcus, we've got 10 minutes left and 25 minutes on the agenda. If I could ask each of the speakers if it's possible to do within 5 minutes, then we can do that. Otherwise, we'll roll it over to an interim. Is there anything you want to say about your last issue?
I think this one is very quick. So like, I don't know if we concluded on this one. Yeah, I guess we can take it.
Yeah, we're going to kind of do something like this, and we're going to
yeah, we're going to do
edit
something like this, and we
37
can
yeah,
discuss
good.
wording and all that stuff. Okay, this is just an issue. I think it's been up for a long time. I would like to close it. There was this question of whether clients should be acknowledging, like explicitly acknowledging that they have received and are going to be actioning on a certain throughput device. The argument for that was that it increases trust in that clients will conform. The counter arguments that have been expressed are like network elements can never assume that throughput advice are guaranteed to be followed, regardless if they are ACT or not. So actually, that additional signal does not provide any value in terms of how much a network element can trust what the clients will do. And the way networks need to deal with all of this is that they will do conformance measurements, just like we discussed in the previous issue. Also, yeah, ACKs, maybe if you lose a packet, then it could be useful with an ACK, but I think the idea here is that SCONE packets are cheap and they can be sent frequently, so loss is not an issue either. You just keep updating these packets as soon as you see them, so we shouldn't be too worried about loss either. So in my view, I would think that we could close this one, but I would be happy to hear if there are any counter arguments beyond what we expressed.
Well, I think you've got the counter arguments up. I think actually what I want to hear at this point for making progress is there anyone for whom this is a deal breaker for the protocol?
No, actually, I opened this one and I'm happy that you're closing it, so I have no problems.
Okay, cool. Good, that was easy. Yep. Put the easy ones first next time. Yeah. All right. Thank you very much. Next up, we have Tianji. Are you able to do this in 5 minutes? Yeah.
I will just skip through all the,
yes.
the background part. Just here. This is just like how to realize the SCONE, the protocol in the 5G scenario.
Yeah, hold on. I did because we switched. It lost. You're good now. Wait, nope. Yeah, now.
Let's see.
Now?
Oh yeah, it works. It's just like the agenda. Skip through. Yeah, here I have already mentioned about the end-to-end architecture. We have to consider this is going to have both the wireless and the wireline part. And for the SCONE, the protocol is going to apply the assume by both the wireless, the 5G network here I'm calling, and the public network here. So for the 5G, I call it the walled garden, since it's going to be restricted by one. The operator is going to have full control about it. So here, and also if you look at the picture, there's from the left to the right is the SCONE the flow, and then that is marked as the blue line, the blue broken line. From the right to the left side is the feedback mechanism is out of band. Okay, here have already discussed with Marcus about how the SCONE policy can be applied from the app server or from the external side through the application function. That is going to be one function of the 5G network, and through the red broken path to the UPF or IUPF there, it's the NE. So those things, the NE on path NE can do the detection, classification, and the mark. So this is very dynamic, and then also it's very flexible the process. Here on the bottom part, you can see the throughput advice will be applied on the intranet in the 5G or in a public network. Remember here for public part, I've just intentionally ignore that thing because that is it's going to be a lot of things have been discussed, but here we have more control on the 5G things if we try to realize. Okay, here is just give this is a lot of the good details about how 5G can be there's some how 5G can realize the SCONE things. Okay, and then for the something can be achieved like per QoS flow granularity because we have multiple QoS flow in PDU session, and for SCONE. It can apply the SDF filter with either static or dynamic provision policies. to the the UDP flows, and then SCONE packet will be processed by the NE or UPF, like sorry about that, with the packet detection rule, QoS enforcement rule, and the forwarding action rule, all kind of things. All the fancy things will be there. It's very flexible and with all the dynamic things. Okay, here I'll just list it because I have to fly through all the things. So a lot of advantage when we try to apply these things, like a dynamic provisioning and realization at the NE or UPFs, or high granularity is the target at achieving the per flow as SCONE throughput advice. And also is very good feedback mechanism because the current draft, SCONE draft, just to say is out of the scope, is a specific to application in use. But as I have described the AS, the server can engage through the AF to provide those things toward the sender side. And also this is for the walled garden. It's like a green field deployment. It will be very friendly. And for the last line mentioned, actually the 3GPP has ever discussed to in one key issue to apply the SCONing in the next XRM phase 3 seed for the release 20, but the last release for 5G. But that one did not finish because going to be discussed in the 6G. So yeah, that's it.
Thank you. Wow, well done.
Yeah,
questions?
about it.
Questions, please take on the list. Sanjay, let's go.
Hi, my name is Sanjay Mishra from Verizon, and along with my authors Anup, Kuram, and Zahid, I'm just giving a quick update on the applicability and manageability. I will not be able to go as fast as you did, but we'll see. So this, let's see.
Oh, wait, we have to, every time we change the slides, we have to give you the slide control again. Okay,
Okay.
here we go. Good,
All right.
go.
Okay. So real quick, so this applicability and manageability draft is retooled from the original use case that I had submitted. And just one thing I want to call out is that network operators are not looking for SCONE, but if SCONE were to be developed, what we're looking to do is how we can make it work and deploy it in the network. And this draft is essentially trying to look into how would we apply this into the network and how would we manage SCONE in the network. So from the last version, we have retooled sections, and there's a section that talks about the applicability part of it, and there are a couple of issues that we have identified that I've listed there. And then on the manageability side, conformance and how to measure the bit rate, and also the window duration, and the dynamic updates. Those are the topics that we want to expand more on. And as you can see, the first two are already issues in the GitHub. And the dynamic update is really just talking about that there may be an ability when the user changes the network from 4G to 5G, et cetera, then there may be a need for network to initiate an update to the client that you're on a higher bit rate or a lower bit rate, depending on what network you're on. So those are the topics that we are trying to address that. To do is essentially review the drone protocol and make sure anything that relates to applicability is picked up into our document and expand on how we would apply and manage. And same thing, we'll go through the GitHub and pick up all the relevant issues on that, and then work through the version 00 to clean that up. And reviews are important, so if you review it, then that would be very helpful to shape the document. You also have access to the GitHub where you can find the document. So that said, I leave it up to the chairs to decide what conversation needs to happen for the adoption of this draft. And the content that we have today, is that sufficient to consider adoption? And if not, then I would like to know how to make this ready for adoption. With that, I'll open up for questions.
So
18 seconds.
nothing in queue. Well done. So chair hat on. I think so. We have two deliverables in the charter. Both are showing we should send them to the ISG in November. I think that's probably wrong. because I think actually this document, in its forms, like you sort of like you pointed out it a little bit in this talk, this document in this form really is about taking addenda to the protocol from implementation experience, et cetera, and saying, here's how you should use it, right? Like there's the part for the operators. There's also really like, okay, here are some things that we noticed that are not like normative language in the protocol. I think we're going to have a larger, more involved, more complete hackathon interop event in Montreal. I'd like that to inform input to this document. There's a question as to whether we would want to do an adoption call before then or in Montreal, but like I think we should take the pressure of, oh, it's got to go to the ISG by this time, because I really do want to take some of the implementation experience and fold it in there. So we should probably do a very minor go to our AD and ask nicely for forgiveness when we push that milestone. I think this is on the right track. We don't have time to have sort of like the hum right now. I would like to get a quick show of hands. I guess you'd have to do a show of hands on the show of hands. Who has read the latest app man draft?
Come on, at least
I'm
more
looking
than
for
zero.
everyone to have a no opinion here. No.
Yeah, there's one.
Please do have a look at this and take it to the list. I think we will want to have a slot specifically for this at the next interim to make sure that we're on the right track and making progress.
Right, because see, it's very simple. If you don't read it, then we can't deploy it.
Exactly.
So if there's no feedback, there's nothing for us to work on.
Good. Can we go to the chair's slides real quick with -1 minute on the thing?
You done here?
Huh? We're done. Yes.
Okay, thank you.
Thank you very much. I guess I could do that, but so before the next, thank you all for staying late. I think we had a lot of good discussion. I wanted to keep that going while we're all here. I do want to say, actually, let's go. Nuts, yeah, this one. This is the main one I want to talk about. Frequent interims seemed like they were useful. I think by the 5th one, people were kind of tired of them, and like we did in 30 minutes, everyone's like, "Can I go home now?" So 5 since Bangkok were too many. I would like us to suggest that we have at least one that's focused on interop hackathon planning, like thinking about how to make the best of our time in Montreal, and that we do that about a month in advance. I was trying to figure out whether I wanted to suggest 1 or 2. Yes?
I have a suggestion.
Yeah.
Can we have 2 with 1 focused on the 2 things that we discussed most feverishly here?
It's like, yeah, so that would be the one on 3rd September, unless people want to do that earlier.
Maybe earlier.
Maybe earlier?
Yeah.
Okay. I'll take that to the list and try to, like, asterisk holidays, right? So I'll take that to the list and try to find some time for that. I think that's a very good suggestion. We should have 1 interim on that, possibly 1 for any other business, definitely 1 for the interop. I will see most all of you at one of those, if not before Montreal. Thank you very much for the discussion and the time and the attention. See you all soon.
Everything's still working.
There are a lot of overlapped things there. Yeah. So yeah, got it. Yeah, take a look and drop me a line about the things. Yes.
Say hi, really? Say hi.